Let's start today talk about something about two-port system approach, and here you have to skip this because this is for not for the stables. Okay. Two-port system approach, it's a system like this one. Show you which one. Yeah. The system like this has AV no load, and for this system, if you can see, we have VI, VO, then we have ZI, ZO, II, IO. See about the current, all current will be inside the system. So I have AV no load, and now I want to calculate AV load, AVS as I explained, but for the system, I don't know anything about the system. What is this? I don't know. I have just AV no load. Is it transistor? Is transmission line? I don't know. I have this AV no load. What is this data? I don't know. Really, I don't know. I have just it's AV no load. So how we can start with this one? Okay. For this one, or for this system, we can consider this approach or model, for example. Let's see this model. In this model, we have like this. We can consider this one. We have RI. We have RI as input, and we have this dependent volt as for other part, AV no load VI, and this is, as you know, this is dependent, this is independent. So this is we have dependent volt. Then we have RO in series. So in this model, as you can see with me, we have RI in input, R out in input output, and we have here AV no load multiply VI. So this is dependent volt source. Okay, and see the others here. For example, you can see AI, IO, VI, VO, ZI, and this is ZO. Now, VO for this system, it's AVI or AV no load multiply VI, and ZO is RO, ZI is RI. Now, if I want to calculate or introduce RL, if now this is, I have this is this one, it is AV no load. Now I will enter RL. So I want to calculate something called AV load. How we can do this? How we can calculate this? Now it's our job. So I want to calculate AV load for the system. So AV load. AV, it's VO over VI. VO here over VI. How can I calculate VO? Okay, I can use, for example, here voltage divider method. That's mean this is VO. So VO here it is AV no load VI multiply RL over RL positive RO voltage divider. Take this under, so VO over VI it is AV no load RL over RL positive RO. So this is what you can say it is AV load. Let's see our book and explain this is correct. Yes, sure. See here using based on voltage divider. So AV load is VO over VI equal AV no load multiply RL over RL multiply sorry, RL plus RO. Sorry for this one. Now I want to calculate AIL. It is I over I over I output here from this one, it is minus VO over RL. This is IO here. It is VO over RL. And another one, it is VI over minus. Why it's minus? Because it's opposite. See the direction? I told you. Here we have. So it's opposite. See, it's opposite. So what it is, we have minus. Minus VO over IO, sorry, over RL. Take RL with RL, so this is the output, minus AVL ZI over RL. In exam, you are responsible just for this formula inside this box. For example, 5.89, 5.80. So for exam. Now, I want to calculate now AVS. If I introduce here, as you see, RS and VS. So how can I calculate AVS? Let's start and see. Okay, I have here, from here to here, it is this one. See again, okay, give me this. This one, it is AV, no load. If I add here RL, it is this one. It is AV with load. Total from here to here, it is AVS. How can I calculate AVS? Okay, I want to calculate AVS. So here it's easy. You can consider this one. Here is it I, and you can calculate as I explained you before. What is it? VO over VI, VI over VS. You can cancel VI with VI, so you can get VO over VS. It's from the picture. See, VI it is RI. This is RI ZI over R plus RI multiply with VS. VS, I see this voltage divider. You cannot follow me, just a minute. Take this. This is ZI. So voltage divider here. So let's see, VI equal VS multiply RI, this one, over RI plus RS. This is VI. Continue. I will take V out. It's a V in all load VI, then take VI as explained before. See. So here it is RI over RI plus RS AV no load. This is AVS. Okay. Can we consider this again? AV no load. What is AV no load? Let's see here. AV no load. Here. So AV load, it is RL over RL plus ROAV no load. This is AVL. What is AVS? Compare. AV it's RI over RI plus RS. Compare. I will take this. Yeah, give me. I will compare both. This one. Yes, thank you so much. Copy. I want to compare between both. What's the difference between those two formulas? But here, where are you? Yeah. Control V. Yeah. Okay, increase. Okay, thank you so much. Okay. Now, let's see and compare the difference between AV load, AVS. AV load is here VO over VI. AVS, it is VO over VS. Okay. AV load is RL. This is RI. In both we are using like this one. See. This is RI in AVS and this is RO in AV load. Okay, so this is RI, this is RL. Good. Over same. In input we have here RS. In output we have RO. So this is the easiest comparison if you want. In both we are using a voltage divider. So in AV load it is RO over R. Sorry, it's RL over RO plus RL. In AVS it is RI over RI plus RS. AV no load, AV no load. AV no load, AV in both cases. Okay, got the idea, got the difference how we can find this easily? Because we have here many formulas. Got it? So focus on how we can find before than memorization. Okay, this is delete. Continue with this our book. So now this is I want to calculate AVS. It's VO over VS. It is VO over VI multiply VS. Now I will write the full formula VO over VS. So it is the full formula here. VO over VS equal RI over RI plus RS. ARL over RL plus RO gives me AV no load in both cases. This is, again, don't forget, this is VI over VS, and here you can start to find AVS before we have AVS. Okay. This formula. If we are talking about just without load, if we start to enter the load, so we have to calculate AV load, and you have to calculate full formula for this one if I take load in my consideration. So first formula it was without load. Second formula if we have a load in our study. In exam you are responsible for these formulas inside the boxes. And this is IL, it's minus AVRI over RL. Okay, now let's take this example and try to solve together. Determine AVL, AVS for network, example 5.11. 5.11 based on 5.1. And in this one, see the question here, he gives to me just AV, no load, ZI, and ZO, and he gives to me also RL, RS. So in this one, he gave to me all parameters. So should I start with AV no load? What is the system? I don't know. Forget this one. In exam, you will find the question like this. See this? See, cancel all of these. And you have determine AV load, AVS, if we have AV load, filan, and continue. So in this case, I will give you just determine AV load, AVS. What is the system? I don't know. Just I have formulas. So I have to apply the formulas. So AV load here is RL over RL plus RO AV no load. He gives me OV no load, yes, here. RO given, yes. Where is RO? Is 3 kilo ohm. He gives to me RL, yes, RL 4.7 kilo ohm. So I can find AV load. And after that, I can find AVS. It is RI over Ri plus Rs multiply RL over RL plus RO AV no load, then you can calculate AVS. And see, this is change based on RS and R load in our consideration. Now, another one, this question came many times in exam, so take care of this question. Given the package, no entry possible, I don't know, amplifier of the figure 5.66. And in this package, he asked me to determine the gain. Okay, AV load and compare it the no load value with RL 1.2 kilo. So he asked me calculate AV and compare to no load. And if we have RL here, it's 2.2 kilo. Repeat with RL 5.6, repeat with 1.2. He calculated AVS and find the current gain 5.6. So here we have just direct implementation for formulas. Start with this one. AV load given, ZI given, ZO given, RL given, R is given. Down. Let's start. So first of all, AV load is AV load, AV load, AV load. It is a voltage divider. Don't forget. So where is the pin? Here the pin. Yeah. AV load is AV no load multiply RL over RL plus ZO. You can directly find the formula from this one. This is AV load. I see RL over RL plus ROAV no load. Now, he asked it about repeat for another value. So this is for RL 1.2 kilo ohm. This is one for RL 5.6. And see, if RL decrease, AV increase. See this one here, 1.2 small, so AV load is 1.180. Now see this RL 5.6. What about the AV load increased? 100. Now we have 300. Same value. RL 1 here 1.2. Here we have 5.6. 2, 2. So if I increase the load, that means AV absolutely will increase. Will it stay the same parameters for others? So if I increase the load, because I have RL over RL, RL here will increase, that means AV load will increase. Now we asked it to calculate AVS. AVS is this one. It is ZI with AV load. This is AV load. I can use two formulas for this one. See, this is AV load. So I can write AVS equal Ri over Ri plus Rs multiply AV load. Is it correct? Or I can take this here to be like this. So AVS is Ri over Ri plus Rs dot RL over RL plus RO AV no load. This is for AVS. I can, this is again, this is, don't forget, this is AV load. So I can use this or this to find the value and see the value here. It's minus 171.361. This is for first case. Now, another part of the question, he asked me calculate or define the current gain directly from the formula. AIL, it's minus. Don't forget minus. We have either one positive, one negative. AV load. Okay. See, AV load. Let me draw the system. AI, this is system. AV, no load. ZI, ZO, RL, and here are the parameters. AI here, it is AI. It is minus AV load multiply this over this. Input over output. minus AV load multiply input input resistance over output resistance. Clear, repeat. AV AI, it is minus AV load. AV load, that's mean multiply input impedance or resistance over output resistance. Hard, easy? Jamal, is it hard or easy for you? Good. Thank you. Good. Who is me? That hard, good. But we have a lot of formula. Excuse me. Try to finish today. Now, last example about today is called cascade system. Cascade system is a system like this one. We have we can say multi-stage. In cascade system, see this one. I have this is stage number one, stage one, stage two, stage three, stage four, and this is RL. Why I need a cascade system? For example, I need big amplifier. So instead of using, for example, one transistor or one stage with big amplifier with big heat, I try to find many things or many stage. So this stage, for example, can reduce or can produce less heat, and maybe it's cheaper than using one big transistor, one expensive transistor for this case. So here we're going to calculate total amplifier and how we can deal with this case if we have multi-stage. So in our study, stage here means transistor. Transistor. So multi-stage, that means we have multi-transistors. How many transistors, for example, if we have n, that means we have n transistor. I'm talking about keytronics. So again, why we need to use multi-stage? We need to use multi-stage to reduce the heat. And for example, maybe using mini stage is cheaper than using one stage. And I give you multiply stage in DC, and today we talk about multiplied stage in AC and how we can calculate the total amplifier. In Darlington, I give to you, we say that's mean beta equal beta 1, beta 2 in Darlington in DC. But today we'll talk about AC, not for DC. If you remember, in AC, we separate each stage. For example, stage 1, so we have to calculate, for example, IB1, IC1, blah, blah, blah. And same thing for 2, and etc. Here, how we can deal with multi-stage if we are using now AC signal. Okay, AC signal, alternative signal. Now let's start with this one and read the this is the formula. AV total in multi-stage is AV1, AV2, AV3 multiply. So in this multi-stage, we have stage 1, stage 2, stage 3, and so on. Okay, so in multi-stage, again, we are using this case. I will multiply first one with second one, with third one, with fourth one. So if I have, for example, three transistors. These three transistors with, for example, 100 amplifier. So 100 with 100 with 100, 100 with 100, 10,000 with 100. Oh, big number. So this is the benefit for using this case is to amplify or increase the current or voltage as soon as possible. Now let's start to calculate or use this one. Again, AI is minus AV total. See, first over over the last. First input over last output. Over first ZI over last RL. Okay. Now let's just take example. And this example, our lecture today, all the question is important for exam. The two-stage system of figure 5.68 employs in transistor emitter floor configuration period conform base configuration. Okay, he asked he gives to me two stages: emitter follower common base. Emitter for that mean here we are common collector, and this is common base. So in multi-stage also you can see from this example that I can connect common emitter with common base with common collector without any problem. So this is also important. I can connect many kinds of systems, not for example common emitter. No, you can use this and this and this as you see in this example. In this example, I have ZI, I have ZO, and I have AV total no load for first one and for second one. And he asked me load gain of each stage. Okay, load gain for each stage. Okay, cancel this. Bye bye. I need for this stage and for this stage. So a load gain, AV load, it is yeah together. Yeah, it's Z01 over Z01 plus RO multiply equal AV no load. AV no load. So we have something like this. AV no load. How we can calculate this? Okay, let's see the example and solve this example. It's here. AV it's ZI2. Why is ZI2? I'll tell you. Over ZI2 plus ZO AV no load. Now let's explain this to you. Okay. Usually, this is our system AV no load. This is ZO, and here we have RO. Good. RO here is ZO, and this is change the symbol to be like your book. This is RL load. Okay. Now totally AV load equal R load over R load plus ZO or RO multiply AV no S. AV no load. Okay. AV no load. Now let's focus R load. R load. In stage number one, I have ZO. This is ZO or RO before. So no problem for that. Where is the RL? RL here is, see, this is RL, this is RL. RL is ZI for next stage. RL here equal ZI2. So in first stage, RL RL is the input characters for next stage. Input characters for next stage. So this is RL. Repeat. Clear this. Go ahead here. I have the system AV no load. I have here RL. So AV load is this is over same thing multiply ZO1 for example multiply AV no load. Good. If I have stage 1 I have ZO. Good. What is RL? RL is ZI2. So you can find here this one. Got the idea? Got the idea? Why is it? Why is it ZI2? So that always load for first stage is input characters for input impedance for next stage. Load for stage 1 is input for stage 2. Important. Usually load for first stage is input for next stage. Is it clear? Take care about this one. Now for another part, okay, let's calculate. For another one, this one is easy. I have RL, so it is AV load. It is okay. AV no load. We have multiply RL here. It's 0.2 over RL plus ZO. You can find it directly. But here is the trick is here. ZI2 equal R. This is the tricky here. Now I found another one. See IRL over VI. So this is RL. It's 8.2 kilo ohm. Then you can find AVO. Here in the question ask me load gain. Okay, load gain for system A for system. So I need to calculate AV load and AV or AV total. AV is for the system. AV total is AV1, AV2, and this is the AV total. AV total. Now, he asked me to find AVS. AVS, it is ZI2 or ZI1 over ZI1 plus RS multiply AV total. AI total, it is also, don't forget, minus AV total. Input over output. Input impedance over last load. Input impedance ZI1 over RL. Doctor, I have 3, 4, 5. No, forget. First one over the last. AI is first over the last. First over the last. First over last. Then you can calculate what you want. Is it clear? Okay. Now let's continue. And return back to the question. The total current we did, the total gain for system emitter for configuration were removed. He told me here in this example, this one cancelled. So I will connect directly this to this. So, okay, this is a system with one amplifier, and you can directly calculate the parameters that you want, like normal case. So see this one, this is it, this question. So here, ZICB, common base, ZI, common base over RS, and you can calculate the rest of parameter that you want. Okay? Any question about this? Last example for today, it's called RS coupled BGT amplifier. And here, this example I give to you before. Let's see this one. Here we have two transistors. So we have two stages. Stage 1, stage 2. And let's check the parameters. This one, 15 same, 2.2, 2.2 same, 4.7 same, 1 kilo same, beta same. So here if you want to calculate R Thevenin 1, it's because voltage divider equal R Thevenin 2, V Thevenin 1 equal V Thevenin 2. It's here R Thevenin 2. This is wrong. Okay. So here we have, and beta 1 equal beta 2 equal here 200. Why is this? Because for each one you have to calculate Thevenin, and you have to calculate R Thevenin, V Thevenin, then you have to calculate IP, then you have to calculate AV. You have to calculate for each one, don't forget RE. So RE1, RE2. R is 26 millivolt over IE. It is 26 millivolt over IE2. This is DC analysis. And IE, it's IE, it is 1 plus beta IB. So you have to calculate IB. IB is V Thevenin minus VBE 0.7 over R Thevenin plus 1 plus beta RE. This is DC analysis I give to you. So you have to calculate RE1, RE2. Here RE1 and RE2 are same. So here it doesn't matter about this one. But if we have different beta, so we have to calculate for each stage RE1. So we have to calculate RE1, RE2, and you have to calculate after that IE1, IE2, then you have to calculate after that, start to calculate the rest of parameters. Here, same, so we don't have any problem. But if they are different, so you have to calculate for each stage. Doctor, I have 3, 4, 5. Anyway, you have to calculate for each one. 1, 2, 3, 4, 5. You have to calculate AV no load. You have to calculate AV no load. I give you AV no load before. AV no load based on the configuration. If you remember, it was RC over RE minus. So you have to calculate for each one. Now let's go to this example. RE, see here the DC bias analysis. Here he told me this is the DC analysis bias. In exam you have to solve. Here he gives to me these examples, but in exam you have to calculate. Now you have to calculate RE. He did RE. Now, what is the problem now? R is now 6.43. Now I have here two stages. This is DC. I want to write or make AC analysis. How we can make AC analysis? Let's start, and this is very important for you. Okay, let's take copy about this and start analysis for this one. Copy this. Okay, now this is the full circuit. I will draw for you the AC equivalent for this one, RE model. For RE model, this is open, this is short, 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 and this is also will be short. So let's start with this one. Stage number 1, I have R1, R2, then we have, I will omit the transistor, so we have beta RE1, then we have this one, beta IB1, then continue, we have here RO if we have, here I guess we have to omit, then we have RC1, then we have, see, it doesn't finish. Start, this is stage number 1. Stage number 2, this is stage 1. Stage 2 is this. I am here, R 1, R2, beta RE. Yeah, then continue here. We have like this one, beta IB2, RO, RC2. We don't have load. So this is transistor 2 or stage 2. So before the answer, excuse me, in exam, draw this one. And here he gives to me this, it's 20 microvolt. So this is, where is it? Okay, sorry, this has been, here is the point, 25 microvolt as input. So before starting to solve this equation, excuse me, focus about this graph. Because from this graph or from this analysis, you can find the answers. Otherwise, not. Now let's return back to the book and see. He asked me find AV1. AV1. AV, as you know, it is minus RC over RE. Minus RC over RE. But see the RC here? This is RC over, this is C. Another color, this is C. See here. So it's not RC alone, it's RC here. We don't have R also. RC parallel with R1, parallel with R2, parallel with beta R over RE. Don't forget minus again. Got how we find it? How we can find it? Got it? From a graph. Without a graph, you cannot get it. So if you want to know how we can find from a graph, is it clear for you? If you repeat, from a graph, you can find the result. This is AV1. Now, here, you can find the value from the calculator. Now, from unloaded second stage, just on the second stage, just it is minus RC over R1. So for first one and second one. First one, this is first one, and this is second one. First one, it is here AV1 load, because here we have another one. Here for second one, we don't have any R, so AV2 unload. Got why? So let's answer. AV1 load. For second one, it's AV2 none in load, because we don't have any load, and so you can return back to the graph to check here. Here, do you have any load here? No. First one, yes, we have load. Load is this one. Here we don't have anyone. So this is AV1 load. Here, second stage is AV2 no load. Clear? Repeat it. Okay, continue. Yes, can you do it again? Jamal, which one? The last part. Okay, this one is this one. So Jamal, see this? This is stage one. This is stage 2. For stage 1, we have a load. This is, so load here is second stage. For stage 2, we don't have any RL. So here, no load. Here we have load. Got it? AV load part. Okay. Again, return back and try to draw the full circuit for each one. If you want to answer this question, you have to return back to the lecture. For example, you draw for this stage RE model, and draw for this stage together RE model, then connect together. Okay, I will try to draw RE model again for you for both. Okay, here. Yeah, this is important for you. It's again, and excuse me, I will not repeat after that. Here, okay, this is for, and this is the RE model. This is ground. This is short circuit, short circuit, short circuit, short circuit, as you know. Now, this is also again short circuit. We have for stage 1, R1, R2. This is for this one, we have beta RE1, then beta IB1, then we have RC1. So this is for a transistor. T1. Clear until now? And this is from here to here. No. Give me this. This is stage 1. Now, continue. Here, R1, R2, and beta RE connect together. Let's go here. Beta IB2. Then we have RC2. Then continue. This is T2, transistor 2. And this is from here to here. Stage 2. And see idea here. Here, T1 has a load, is this one. So they can't calculate AV load because we have a load. Here for this one, we don't have RL. We don't have RL. So we can say it is AV2 no load. Got it? Got it? Clear for you? Easy or hard? A little bit hard. Yes. So excuse me, repeat this lecture again and again. Because in exam, you must, if in your book they didn't draw for you. But I did for you. So excuse me. Draw this to answer this question. It's easy. A little bit long, but it's easy. If you answer without drawing, that means it will be hard for you. Clear? Okay. So again here, AV load, AV no load, AV total. It's AV1 load, AV2 no load. Then he asks me calculate VO. V total with VI, he gives to me VI, yes, from the graph, 25 microvolt. What is the output will be here? 900 millivolt. So it is increased out 10,000 times. So let's calculate, for example, how it's a percentage. It was now it output it's here 202.25 exponential 3 divided by 25 exponential minus 6. So about 3. See this number. Oh, 36 kilo amplifier. Big number. Big number. Sure, big number. So if I have 1 volt, it will be 36 kilovolt. If I have 1 volt, it will be 36 kilovolt. It's a big number. Okay. So it's a big number, not easy number. Now, after that, you calculate VO, it's AVT. VI, then calculate impedance for input and out. In cascade connection here, you can see in this example, this is an exam, I will stop here. As you can see, we can connect many stage, for example, common base with common emitter as you want. This example is cancelled. Here, 5.16 is cancelled. Just I will stop in this example. Which one? What's the number for this one? It is 515. It's included. After that, it is cancelled. In Darlington 517, beta D or beta Darlington is beta 1 plus beta 2, and that is, we don't need more for this one. Just you have to know this. In Darlington usually is a one circuit or one chip. In Darlington, beta T is beta 1 with beta 2 without more explanation. Emitter follower configuration, this is cancelled. We don't need this one from you. We don't need this from you. Just calculate total beta for each stage. Now let's go. This is cancelled, 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 cancelled. As the Darlington, if you want to see this Darlington, this is the package of Darlington. It's like a transistor, as you see, but here we have 2 transistors inside this one. Darlington, just I need beta equal beta 1 and beta 2. Next week, inshallah, we start with 5.19 hybrid equivalent model. Next week, we have a quiz. Next week, we have online quiz. Next week, we have online quiz. Clear? Next week, we have online quiz at 9. From now, I will announce to you. Next week, we have online quiz at 9 on UBIS. Clear? Next week, we have online exam at 9 on UBIS for everything that I give to you. And this quiz is 20 marks. Yeah. Next week, we have a quiz, online quiz from everything until this lecture, and this quiz will be at 9. Clear? Any question? Friday, yeah. Same time, same time, but not 8, not from 9. From 9. On the UBIS, multiple choice on the UBIS. Yeah, that's for today. Take care for yourself. Try to study hard. You have 1 week. Have a nice